Okay, I have started recording and I'm gonna, let me just see what behind me looks like. So the reason I'm turning on my camera is because I need you to look at me and listen to me when I talk to you. So guys, do not come into these stats classes stressed out. Okay, it's not gonna help you. And you will get it, I promise. You will understand. We will work in all the support necessary. We will never, ever, ever leave you all by yourself confused. We won't do that. Nadia's here. I'm here. You're going to have several stat tutors run tutorials. You are not alone. But if you're going to be super stressed out when you come into the classes, you're not going to hear. So I want you all to grab a cup of tea, a glass of wine, like Milo, I don't know, anything, and get yourself into like a relaxed space. We're just going to talk about linear regression and recap what we did in the last class. We're not doing anything scary, I promise, and you will be okay. But if you're going to sit here, I can't do this, numbers are difficult, all of this, you're not going to put your head where it needs to be. So when I did my first stats course, I thought I was going to vomit in a dustbin. And if I think back now, that was really, really silly. But I ended up with a lecturer later in my studies, not in my undergrad. I would say that was even in the first year of my master's, with a lecturer who just really took the time to take us through it and make us understand. So please just, who saw? Last time you guys were so stressed, I think I went to bed stressed. And I love this stuff. So just breathe. Take it really easy. I'm going to turn off my camera in a minute because I should have looked at what I look like before I turn it on. Just breathe. We're going to go through it again slowly. And then we're going to obviously move on today. We have to, but even if we have to slow down the pace, there's lots of things, okay? Just breathe. So let's quickly recap and go through what we did in the last class. We're going to work with that Excel spreadsheet. And we're going to move a little bit into linear regression and talk about error rates at the end of that. Okay, but we're going to go nice and gentle and slow. And remember, if we don't absolutely cover everything in this 2-hour time that we have, I can always record short videos for you. I don't want to rush you. That's also not a good idea. So now I'm going to turn off my camera. I'm going to share my screen. And I'm going to ask you to take a deep breath. Let's do this. Okay, can you show me an indication in a reaction or anything like that, that you are breathing? Okay, right. Now I shall bring up the Excel spreadsheet and share my screen. Okay, and figuring out how to close Signal so that it doesn't pop up. Well, messages are going to pop up. Okay, right. So in the last class, we spoke about the equation of the line, all of these things, okay? So this first sheet in the Excel spreadsheet that I gave you guys has the data that we've worked with. And here we're seeing that that data is linear. And if we double click on this chart, we're going to see that we're actually only looking at 2 features. We are looking at the fish's weight. So how can we use height to explain a fish's weight, or how can we use height to predict a fish's weight? Okay. And there's several formulas that we can do this with. They can range from very complicated, that makes you want to throw up, to much, much, much simpler, because in the end, what we're really doing is we're just fiddling with that equation of a line. However, where the equation of the line can become a problem is in the equation of a line, we actually cut directly. My line moved. Why? We actually cut directly. Oh, I made my data points. We actually cut directly through the data points, and we have super, super clean data. That's not the case in the real world. In the real world, data is noisy. So we can see that this data is definitely there's no line we can really draw that will cut through every single data point, giving us absolutely no residual. Okay, it's not possible. But we can draw a line that's pretty dang close. Okay. So one thing when we talk about linear regression is the data must be suitable for linear regression. So we see this beautiful grouping of data in a line here, and we can see there's linearity. We can sort of eyeball this. This is not even needed for the correlation. But if you couldn't eyeball it, you can also go and just work out the correlation. So here I've just used the Excel's correlation formula, and I said work out the correlation for me between height and weight for the fish. Okay, and we will do it together on the next slide. Don't worry, and I'll break the formulas 9 times. We'll be fine. Okay, and then we get a very nice correlation here of 0.96. So what that tells us about this correlation, who can tell me what is 0.96? It's an example of a what correlation. Who wants to type that in the chat? Dominic, your hand is up.
If I'm not mistaken, it's positive correlation.
Yeah, that's a really strong positive correlation. So correlations can be negative or positive. So here I've got some more information for you and another stuffed up line. And I think you have to actually in your assignment use the Correl formula. But the Correl formula is just equals Correl for correlation, array 1. And oh, yeah, man, guys, I'm so sorry about this new laptop. Look, it's a lovely machine, but this trackpad mouse has cost me so dearly. Okay, and an array is just a table representation of data. So if we say this is array 1, okay, comma, array 2. What is the correlation between these two columns of data? It will give us that correlation. And I often forget Excel formulas and I have to go look them up. And you should do the same. They're not going to be stuck in your head. I often forget a million things. This course is not about remembering everything. That's nuts. This is postgrad. You have the opportunity to look things up. So I don't know what I've written here as no. But a positive correlation is if one value goes up, so does the other. A negative correlation is if one value goes down, so does the other. A strong positive correlation is from 0.8 and up. It's between 0 and 1. A weak positive correlation is an example of 0.6. What I meant here with no, only I will know. This is a guess. There's really, if you hit 0.5, it's a guess, and it doesn't matter anymore. It's 50-50. Whether anything is going to matter. Okay, so we like to see this linearity. So now that we know we have linearity and this data is definitely linear in nature, we can work with linear regression. So we're going to do basic linear regression. We're going to look at it. We're going to go test it. And then we're going to move to OLS. Okay, so far, is everybody okay? No one is feeling ill and need a hug. All right. So let's look at an example where we're just looking at a single data point. So we're going to choose this guy over here, which says this is a series. Point 1 is 11.5 and point 2 is 242. So we're looking at this guy. Do you guys see this? So we can then use the equation, the simple equation of a line before we move into ALS, and we're going to see why the equation of a line isn't going to work. Okay, so let's go work out the equation of a line. So it's going to say, Y is our prediction, we know this, B is our intercept, M or W, depending on the formula you're looking at, is the slope we need to calculate, and X is the given value. So we are going to calculate a slope here, and we're going to assume an intercept of 0. So it's just a starting point. You can very often assume an intercept of 0, and we'll talk about it more as we go. So if it seems fuzzy, just go like we're assuming 0. The rest will come. Don't overthink it now. So we find any point of the line. Check. We find the 2 points, and we divide them by each other to get that slope. Okay. Or your rise over run. Here is another data point that does that. And I just chose a random data point to say to you guys, this is per data point. If we're going to look here for 13, there he is. This is a random data point because these are just data points. We're just looking at individual points, okay? So if we work out that slope, if we go and say, divide these two by each other, that gives us the slope, okay? Then we have our intercept, and here is our X value. Then we can use the equation of the line to calculate our Y value. We can definitely say Y equals X28 which is my slope, times x30 plus x29, my slope and my intercept, and it gives me that 242. We can go do the same here, and we can say, okay, if I take y equals my slope, m, times my x value, and in this case, the intercept doesn't matter because it's 0, but let's add m, plus my intercept, I'm going to get that perfect 242 because this is 2 points. The line cuts directly, just this little point we've worked it out just for here. And then the normal assumption would be like, haha, I am done. And we can even go and make the ones that are should be absolute values. It's not going to make any difference. If we auto-fill this down, so let's go do this formula a bit better. So let's go say, okay, y equals m, but this is our m. So I'm going to hit Fn, F4 on my keyboard. It might be different on different keyboards, okay, times x plus my intercept, b, and I also make that an absolute reference, just meaning Excel will only use that single cell. And if I start auto-filling this down, we're going to see that the values are going to be very far off. Do you see this? 379 for 950, 953. This is not at all accurate. It is because we can't use just this to draw the line, because if we use that, we're going to miss a whole lot of things. The line's going to come out somewhere here. We actually need a representation of this noisy data. We need something that represents them all. Then I recorded a short video for you guys because someone asked me in the last class, why do we even use this formula? So I showed you the different things that would happen in a short recording, that there's a formula called ordinary least squares. Why is it called ordinary least squares? If we want to draw a line, so now I'm going to go to OLS here. Do I have a chart here? I'm going to swiftly go back to the chart. If we want to draw a line of best fit, we're never going to get the perfect line that cuts through the data points. We are going to get a line, wave shapes. We are going to get a line that looks something like this. And that's my guesstimated line, okay? All right, and let's go make that line red so that we can see them. And we will obviously miss some points, okay? And that is our error. That's our percentage that we're not correct. And we want to draw the line, obviously, that we are wrong the least. We don't want to suck. So what we do is we go, and in machine learning, and you guys will see a bit of it tonight, that I'm afraid to show you the calculations because that comes later. But in machine learning, we're actually going to draw a zillion lines until we find the best fit. Okay, that's programmatically. Statistically, now we're only going to look at one line. So what we then do is we go like, this is where my line is, and this is where the actual data point is. So I must actually just subtract the differences here, and I will find my error rate. And if I add all of these differences together, I will get how big my boo-boo was. And I want the smallest possible boo-boo. So if I go and I now say, okay, let's go work out the residuals, because that's what we call our boo-boos. Okay, let's go work it out here. So we will say then, okay, the actual Y value, which is the weight, minus our predicted Y value. So for that perfect one, yes, no problem. Look at us, we're geniuses. And then, dun, 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 maybe we're not so smart because these residuals are huge for that individual slope and stuff that we just used. It doesn't work. And we have groot nanas here. So to get past it, and to get to the point that see this mouse, to get to the point where we can draw a line that takes these errors into consideration, we're going to use OLS, ordinary least squares. Are you breathing? Every time I click back on here, it's when I want to come see if you guys are still alive. Nobody's crying in the corner. Okay. All right. Yeah. Nyasha, your hand is up.
Sorry, ma'am. Pressed the wrong button.
Ah, don't worry. I do that daily. And then I forget my hand up, and then in the meeting, they go like, why's your hand up? And I'll be like, oh, sorry. It's a legacy hand. Okay. So let's go look at ordinary least squares. If you still have questions about where this formula comes about and why we did it, I made a short video for you guys. It's on the WhatsApp group. It's on the YouTube playlist. I am so sorry that I am not yet on ARC. There's some kind of issue. Both Nadia and I got yeeted off ARC. Okay. I want you to look how much better these residuals look. All right, so let's look at this OLS and how it's calculated. Okay, and then we'll go calculate it together. So we're going to talk through this example, then calculate OLS. Then we're going to look at another example, and we're going to talk through multiple linear regression, and we're going to do a multiple linear regression example. Okay, right. So in this case, we are still only using height and weight, okay? We are not using the entire fish. So we're just using a single feature, okay? So we're using height to predict, estimate, infer weight, okay? Now, to do that, there is a formula, okay? For us to get, because to draw this line, we need two things to draw a line. I need to know where to start the line. So here is the intercept actually at 0. Not that bad. So I need to decide, see, where to start the line. That's my intercept. Where do I cut the y-axis? And then the thing that I have to play with the slope is the guy that does this. Okay, so I have to calculate then that angle of the line, gradient, magnitude, all these things that people call these things. That's just how the line goes, like wee, okay? We need to calculate, we need to decide that. So in order for us to draw a line with Emeris, we need a single slope and a single intercept, where we are recognizing all of these data points and we're making sure we have the smallest little error. So this is how we use all of this data points, this noisy data, to get a single slope and intercept. So this part of the formula is to calculate the slope, okay? And then underneath it is to calculate the intercept and then to draw that line, okay? So let's go take a look at how you do this. And what I'm giving you guys here is a recipe. I actually was thinking the other night after I taught you guys, who taught me this recipe? It's all over YouTube, but this is a very old recipe on how to do this, a recipe you can learn off by heart if you're such a person. Okay, so what we need is these components of this formula. Okay, we need n. So if we look at this picture, what do we need to calculate the slope? Well, we need n. N in statistics is the number of observations. Let's go find our number of observations. So we're just going to say, let's count. And all I've done here is I've just copied over the height and weight column to make things easier for you guys to see. Okay, I've just literally taken, before I break everything here, height and weight from over here, and I copied them next to each other here. So we need to get our n. And we can see this is our n because it's the count of this entire column. Okay, then it says we need the sum of x times y. Well, then certainly we have to have x times y. So we just make a column for us and we go and say, this mouse, x times y. So this formula is literally every time just x times y. Do you guys see this? No, I'm clicking on the wrong thing like a no-no head. Okay. Why is this thing doing that? It's going to drive me insane. There you go. X times y, all the way down. That's just, we've just taken the x values and turned it to the y value. So what you do when you start with OLS, you go find your target variable or your y, which is your weight. You go find your feature or your x, which in this case is your height. Copy them over and put them next to each other here. First step is we need x times y. Well, we better x times y this. And this dude here is the sum. We need the sum of x times y. So this says this cell holds y34. Do you see that this is y34? No, man, y43. And it's literally just the sum of this x times y column. Again, remember this, raise it like a recipe. Then the next thing we need minus the sum of x times the sum of y. Well, then we better go sum up x. Did we do that? Yep, we have definitely summed up x. And we just get the sum of y. And I like to make myself this little table where I put them because it makes my life easier. Then we also look at the bottom here and we go, oh, we also need m times the sum of x squared. So we better go square x. And that's all we did here, is this is just another column where we just squared x. Okay. And then we minus that by, and this is where I got a lot of people confused. This is a column we have calculated. Here we just square. We're going to say minus the sum of x and we square it. So what does this formula say in English? It says the number of observations, n, times the sum of xy, minus the sum of x times the sum of y. So I've just typed the formula out for you in English. If you are someone that hasn't had math since high school, when you're like, this formula is like, what the F and F, that is what the formula means. Then there's our division line divided by the number of observations, Rn, times the sum of x squared minus the sum of x squared. Okay. And here I've typed it out for you. If you don't like the words, I've tried to be like people like this, people that like to see the formula, right? There's people that like to see the words, right? There's people that like to see the calculation, right? Okay, because here we then said n is definitely 35 times the sum of xy. There's the sum of x times y minus the sum of x. That's definitely the sum of x times the sum of y. Where is our sum of y? Do you see these numbers matching? Divided by 35 times the sum of x squared minus the sum of x that we square. And if we do that, we do this little calculation, we end up with a slope of 102. Okay. All right, but we can also just do it in an Excel formula where we can go work it out, and we're going to do it on the next slide, where we literally go and say the same thing. This is for you to understand what I've done to get to this number, and me is working it out for you manually. Okay, so you can follow here. But here is how we just quickly do it in Excel. And then I think I had a minus somewhere in the last class and messed up my brackets. I'm always going to make errors in class in front of you because I need to normalize it. I need you to understand that you are going to get confused with the brackets, miss a bloody thing. The Excel's going to throw that annoying block at you that goes ding, 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 ding. That you want to break. You're not stupid. You're not dumb. You're just calculating stuff in Excel. So I'm never going to prep a perfect lecture because I need you to see me be faulty so that you are not scared of being faulty. Okay. So what does this formula mean? Let's see. Well, look at that. S16 looks to be 35, right? That is, oh my words, n times, what are we timesing it with? What is in S14? Would it be, and this is where I get confused, the sum of xy minus, okay? Do you guys see this? The sum of x. Do you guys see that? Times the sum of y. That is indeed the right place. And all that we're doing here is we're calculating that in brackets to say, please calculate for me S16 times S14, or n, times the sum of xy, then minus that by first calculate the sum of x times the sum of y, then get that number exactly like I've done here for you guys and divide that. That's what we're doing with the brackets. The brackets is just using BODMAS saying you cannot divide before this. You cannot subtract before you've done these two brackets. So solve this bracket and solve this bracket, then subtract. You cannot divide until you've solved all the inner brackets. So solve this bracket and then this bracket and then subtract. Only once you have two whole numbers here are you allowed to divide. And that takes you to your slope. And we are just applying this formula. So make your little table, and we're going to do it together on the next slide, my next sheet. Make your little table, plug in your little pieces, and I will always copy the formula over for you in the sheet so you have it if you want to lose your mind. But things shift as I copy and paste. But you'll always have the idea of the brackets. And also, when I do these formulas in class, I also always need you guys to watch me and go like, Serena, you've missed this, you've done that wrong. It helps me to know your thinking. It helps the class to also be okay with errors, all of these things. Then I copy and paste it down again because I'm old, okay, and I want my stuff where I want them. I don't want to scroll up and down. But I mean, then we do the exact same for the intercept. Oh, my word. Sorry for the fright. My family just came home. We do the exact same for the intercept, where it is the sum of y minus that slope we have calculated times the sum of x over our observations. And here we're doing exactly that. The sum of y minus that slope times the sum of x over a number of observations. And then we get that slope. Okay. So absolutely doable, and we will plug in the formula for the slope as well. And then once we've done that, we have a y equals mx plus b. But we can actually auto-fill this guy down and look at these residuals versus those residuals. Look at these numbers. Look at these numbers. We have definitely minimized those residuals. Are you guys breathing? Tabiso, is your hand up?
Yes, my hand is up.
What's up, Tabiso? Ask me.
I just wanted to ask a question. If we go back to the spreadsheet,
Yeah?
I think we have agreed and discussed that there were 6 features for those species, right?
Yes,
and
but
you are saying that we are using height to find y, right? Which is the weight. What determines that? So what would be a case where you say I will use y as a weight to determine x as a height?
Okay, in this case, it was just a guess, just to show you guys with just 2 variables, but it is a practice in statistics and machine learning, which is called feature extraction. So you would actually look for the feature that best works, and we usually do that with a correlation matrix, and you choose the one with the highest correlation. In this case, a big fat cheaters, if you look at the numbers, height is absolutely the highest correlation, so it is the best variable to do it with. But that is not what I did when I did this. I just chose weight and height. But you would look for the variables with the best correlation. So you would work out, if we go back to this big table, you would work out the correlation for each of these. So like we just worked out this one correlation. You would then go and work out the next correlation as well. So you would have said equals coral, and then you would have said, in this case, I'm going to use length 1. And I'm going to take that against, I almost took width, height. So this is called feature engineering or feature extraction. And you would have seen that this one's slightly lower. You would have chosen the best one and you would have worked out all the correlations. Okay, but for this one, it was just a guesstimate. And then you will, before we leave the end of this class, actually use all of them in your calculation. Okay, so I needed you guys to see simple. Let's start small with OLS with 1 target variable and 1 feature so we can understand. And then we move into multi-feature. The way you choose your features in linear regression specifically is with a correlation matrix. And then for those of you that are deep stats fundies, and we'll talk about it later, sometimes just what happens with correlations is while these guys are all correlated to weight, they're also sometimes correlated to each other, which is known as multicollinearity, which we unpack in PDAN and how to deal with that. So just park it if it was in the back of your head. The people that are not stats fundies, forget I said anything. People that are stats fundies, park that in the back of your head. We will deal with it in PDAN programmatically where it's easy. Okay. Did I answer your question?
Yes, thank you.
Okay. Nobody at this state is hyperventilating, right? Okay. Right, so let's go practice this. And now you are going to help me, and that's an extra copy because I'm a bit doof. You are going to help me do this now, because now we have an empty guy here, and we are going to do our stuff. All right, so you're not going to just leave me hanging here. All right, so the first thing that we do is we look at our formula, and we say, okay, what are the bits that I need? We make our table with our bits. We say we need n. We need the sum of x times y, x minus the sum of x times the sum of y, and then we also need the sum of x squared. So we need all of these to be able to build this formula, and you can keep this recipe and just remember it. Okay, so the first thing we're going to do is go work out all our areas. So make your table and then make your life easy and go calculate x squared, which is super easy. Equals, we're going to say x squared, like this. And we're going to drag that down. Oh, I forgot to delete that one. Okay. Oopsie. Okay. Then the next thing that we have to go work out, okay, is for each xy point, calculate x squared and xy, which is x times y. So then we're going to say, okay, I need to take x times y. Did I do that right? Why is that blue so hard to read? Okay. And we drag those guys down. All right. And I also didn't delete that one. It's going very well. Okay, so now we've got this table complete. And now we look, we say, okay, we need the sum of x. So that's very simple to do. We're just going to say equals sum. And I'm just going to drag this from a bottom up. Excel will correct it's like range if it bothers OCD people. We're going to say, okay, there is our sum of x. And we're just going to say, okay, we just would like to have it over here. No, man. We would just like to have it over here in our little table to make our lives a little easier. So let's go grab them. Okay. Then we're going to be super lazy because that's why we said you guys can use Excel to save you some time, and we're going to drag this along. Okay. And then we're going to go complete our table. So we're going to say, okay, inside here, we need the sum of y. And people, please double check me. I am aged. It is 7 o'clock at night. I click on the wrong things. Okay. All right. Then we need the sum of x squared. Okay, so we can absolutely do that. Let's get the sum of x squared. And let's get the sum of xy. And now I'm probably going to stuff up that formula again. So I need the formula kitties to pay attention. All right. All righty. And now I need my n. And we're just going to take the first column. We're going to drag it down. And there is my n. And now I've broken something. Bye. Because I haven't said count. Why are you people not checking my DOF? Okay. So there we have all of our values in place. So let's go and calculate that slope. Okay. Right. The Excel way. So let's go do it. So we need to say first brackets, divide, brackets. Excel's going to drive me nuts with this. And we're going to put in that equal sign at the end. Okay, inside those brackets, we need to say, okay, I need another pair of brackets. And now let's give the equal sign and let the suffering start. This might not work, okay? So in this inner brackets, okay, starting with the first thing that we have to do. The very first thing we have to do is we have to work out n, okay, which we've got there, okay? So n sorry for the coughing in your ears, okay, times, oops, that's also not right. So we have to take the number of observations which are in times the sum of xy. So we go find the sum of xy. From that, that needs to be calculated. Then we need to subtract from that the sum of x minus, I did that last time as well, times the sum of y. Okay, once we have this calculated, we want to divide it by the number of observations times the sum of x squared. Okay, and from that, yeah, man, from that, we subtract. Have I stuffed this one up now? Definitely. Must be there. Let's just fix you. You must be there. Okay, minus. I'm expecting you guys to be checking my formula. Now we've lost a bracket. It's going very well. Minus the sum of x. No, man. Now I'm just going to do it again. I swear it's the keyboard. Minus the sum of x. And we're going to square it. There is your formula. There is your slope. You have done it. Follow the recipe. Is everybody okay? Are you all breathing that you are able to calculate that slope? Does this make sense? Yes, Cindy Siwe. Cindy Swa. Cindy Siwe. Oh, I'm so sorry. Okay. So let's go now and calculate our intercept and work out our residuals. Okay. So let's go calculate our intercept. So the formula for the intercept is not count. Let's just get our n back here. We've lost it. I'm going to throw this keyboard away. Okay. I could have just typed 35. Hey, but generally you don't want to type stuff because sometimes you copy and paste something and something changes and then your formulas are all wrong. Okay. Now let's go calculate our slope. Okay. So to do the slope, we are going to say equals the sum of y minus, we might not need these extra brackets, minus the slope we just calculated, okay, times the sum of x. We got this. No, man, I can do it myself. Okay. Excel is super persistent. I was still thinking about it. Divided by n. Bam, bam, bam. Oops, that went all wrong. Let me see what we've done wrong. Let's go do it again. Now to work out our slope, we have to do equals the sum of y minus our slope times the sum of x. Oh, those need to be in brackets. No, go away. I'm just putting in my brackets. Go away. Divided by 35. And there is our slope. And I will also copy and paste this formula for you so you have it, because this is not an Excel course. You can have the formulas. Okay, let me just escape it before it does weird things. Okay, there's your formula. So there is our slope and our intercept. So now we want to know, did we actually do this right? So we are just going to do a little checky check. Okay, so what we're going to do is we're going to use the built-in data analysis tool. So let's go say data, and there's data analysis. If you don't have it, you're going to click on File. You're going to choose Options. You are going to click on Add-ins. You're going to go to Manage Excel Add-ins. You're going to click Go. You're going to tick that Analysis Tool Pack and click OK. and she will appear. So we're going to click on data analysis, and in your last class, I was looking for linear regression like a dada. It's just regression. You're going to go find the regression section. You're going to say, okay. And now what I'm telling you, you will remember for the rest of your life. Once you know the OLS calculations, you never have to do them again. You can absolutely use the data analysis tool pack. But using tool packs and stuff, when you don't understand the underlying math, makes you a really bad data scientist. So then it says, okay, give you a Y range. So what is our Y? It's what we want to predict. We want to predict some weight. Okay. Then it's saying, okay, and give me your X range. And to do that, we are using height. Have I highlighted everything here? People must double check me there. Okay, so we've got this, and I'm going to say, I don't want this on a whole new spreadsheet. I would like an output range. I'll tell you where to put the data so that I can double check myself carefully. I'm just going to take a whole, no man. Oh man, just going to take a whole chunk of space here. Thank you very much. Stick the data in there for me. And here it will give you your intercept and your slope. And because we're only using two variables, were we correct in the intercept? And so were we absolutely on the money, the same value as the Excel tool pack? Were we? Really? After all of that hard work, you don't even say yes? Okay. We were absolutely on the money because this is the slope. We calculated over here all by ourselves. We got 102, 704, 726. Okay, there's a little bit of rounding here. We'll forgive Excel. And then over here is the slope we calculated, which is minus 941,559. This one is absolutely on the money. Okay, so there we go. Totally doable. Okay, we just get some more decibels here because we are more classy than Excel. Now we can go do this. So if we now want to do OLX, we are going to say Y equals, okay, MX times B. In this case, RM is here. In Excel, I'm going to highlight them and I'm going to put F and F4 on my keyboard to make that an an F. You know what I'm saying? An absolute value times, here is my X, plus my B, which is the intercept we have just calculated ourselves. And we're just going to make sure that we make those absolute values. And these dollar signs just means that Excel won't change the cells as we drag. Okay. All right. Something here went very wrong. Let me go see what I've done here. So basically, what we do with an absolute value is we just make sure that Excel will only ever use this one cell. It won't use another cell. Okay, right. So let's do this again. Let's see what I have stuffed up. So we can say Y equals, or our OLS, our Y equals our slope, which is definitely there, which we have to make an X, okay. Our slope, yeah, 1. Let me just take the X value times the slope we have just calculated. Make that an absolute value plus our intercept. We could also just plus 0, by the way. Okay, plus our intercept, and that should give us our value. And that, yeah, thank goodness that fixed it. It was really that. We can actually autofill down. Is it going to be perfect? No. Is it going to be significantly better than the other ones that were terribly wrong? Oh, no, we made a boo-boo. Let me go fix my boo-boo. Who's going to tell me what my boo-boo is?
I think it's the formula. I think it's the sequence of your formula, because I'm thinking if you're saying...
oh, you can switch them around. I didn't make this an absolute value. Okay, that's much better. But you are right. My sequencing now equals y equals x times m plus b. That
yes,
you
that's
can
what I was
plot
thinking.
around. Yeah. No, you can do them. You can swap
It
them
makes
around.
sense. I mean, it will make sense if x times m or m times x is still the same thing. But if you
Yeah,
want to follow the formula as it is, you will go m, which is your slope, and multiply it by your E8. I think it's E8 for your first height.
Yes.
And then you plus your B.
Yeah, you got it. What the booba I made is I didn't make this an absolute reference. An absolute reference means if do you see, look at E8 and where E8 is. Now if I go down in Excel, it become E9, E10, E11, E12. So as you autofill down in Excel, it increments the cell number. If you don't put these $gedoentekies, it will do the same here. So that will go down. It will start taking random cells here. So if I remove the $gedoentekies here, so let me go break our thing and then we'll fix our thing. So let me start over here. And if I remove the $gedoentekies, which is just an absolute reference, that's the real Excel name for the $gedoentekies, okay? If I do that, and if I autofill this down, it is automatically going to autofill all of them. Do you guys see what's happening? All of the values are changing and it's no longer timesing by our single cell over here, because we should only times by this for the slope and only by that for the intercept. So if I don't do those absolute values, as I start dragging down, it's going to do it right the first time, but then it's going to say 3862. Then it's going to say 3963. That's why we put the $gedoentekies, because if I then autofill all the way down, or you can just say absolute reference, you will see the only thing that will change is E8. Only our x variable will then change, and our slope and intercept that we're using will remain the same. Do you see this? Now we can go work out our residuals. We can say, okay, this is our unknown value, okay? And this is our y, and this guy here that we've calculated is known as y hat, or our prediction. And now we can go say, how much were we wrong? And like I said, it's going to be a bit up and down, and this is just one iteration, but this is infinitely better than that. Okay, if you look at this. So those are your residuals. And we want to do it, and we have to square these residuals. And there's a reason we have to square these residuals, okay? So I'm just going to put in another column here, and we're going to square them. And I'm going to tell you why we need to square these residuals. Because something like this can happen. I'm just going to cheat, okay? So, and it can end up with, okay, also we have negative numbers, but 2 might completely cancel each other out. That might happen. And then mathematically, that doesn't work for us. So you always work out your residuals and then you square them. Because if we go square them, oh, now the spelling doesn't want to work. We make sure that we don't accidentally cancel out things. So if we're going to say, you're going to tell me now what happens after we've squared these. There will never be a 0, and there will never be a negative number, so that we don't end up accidentally canceling out errors. That is why we square the residual. So that's why it's the sum of residuals squared. So we don't end up in an instance where we have a negative, and it could be a negative and a positive here. So let's say we want to work out our residuals squared. We want to add them up, and we have 2 of this errors exactly the same. We have a minus 48, blah, 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 whatever this number is, and a plus 48, blah, 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 what that number is in by chance. They're going to cancel each other out, and we're going to lose that bit of error. But if we square them, that won't happen. So that's why we square them, so that we don't end up accidentally with values here that can cancel each other out, and that we don't work with negatives. That makes sense to you guys? Thank you, Kat. I saw I didn't lock. Okay. So, and that is why it is called ordinary least squares. There we go. Now, are you still panicking? Do you feel in control, or are you still vomitous? I think the first time you hear these things, you always want to throw up a little bit. Yes, you always have to, well, you know. And ask me this in 5 minutes. Okay, and Kat, then I'll take your question.
Sorry,
Yeah.
I like that other step that you had just now where you're using it to check your formula. Do you already have a short video of that on the group, or am I
What
just
step
gonna
did I take to check my formula?
Yeah, where you I think you went into the data and then you it's like
yeah,
when
yeah,
you're
yeah.
doing VLOOKUPs. Yeah, it's a similar
Yeah.
way. Yeah. Do you have that in the group already?
Yeah, I have that in the group already. And I want to show you guys a really neat Excel trick as well. If you highlight the data and you press Control on your keyboard and the button right under Escape, that's a tilde or an apostrophe, it will automatically show you the formulas used. And then you can just put it back. Okay. I don't know. It's right under Escape, Control, and that button. It's called a tilde. All right. So that is if we use a single variable. The question about the residual squared. Okay, this residuals we have here, the error is actually in grams. Okay, with this fish, we are 0.4 grams off. With this fish, we're minus 50 grams off. We've made some boo-boo here. So when we square them, we step out of grams. It's no longer grams. Then it is difficult to interpret. So and then because we will now going to go work out how wrong are we? And that is to answer that question, I need to show you this, and we're not going to go too deep into it because we do it tonight. But there's the mean squared error where we work out the average of this column to say, on average, how far were we wrong? And then people realize, damn it, but I want to know how much am I wrong in grams. Then they were like, okay, but why don't we just do the absolute value? Because an absolute value is never a negative. Okay, so why don't we just use the absolute value, and that brought the mean. Oh, where's mean absolute errors? When did you forget to put it in? That brings the mean absolute error. So sometimes we square, it depends. You should always do something with them. So the norm is to square, but we can square, we can take the absolute, we'll talk about that. So technically, no, you don't always square, but you always do something to account for those nasty zeros and counting against each other stuff. Did that answer your question? And we will be looking at the thingamabobbies, the error calculations metrics, the error metrics next. From a graphical point of view, what do the OLS and residual square values tell us? Okay, that's a really good question, Alizwe, and we're going to discuss that in the evaluations, but it tells us how badly did we stuff up and if we can trust this model. So in this case, if we go work out the R squared, and we'll talk about it, we will be able to say that we can explain with the fish's height, we can explain 93% of its weights. So for 93% of our data, if we have the height, we can explain the weight, or we can explain the variability in weight. And we'll do that when we're looking at the evaluations. We first just have to look at multivariate OLS, and then we're going to go look at the evaluations and the ones we do. And then you guys will actually know everything for your assignment. Okay, because that's your assignment, I think, is ask you correlations, all of this. All right. Okay, can we move to multi? And I always want to say multivariate, but it's not, because that's univariate and multivariate, very different things. We are moving to multiple linear regression, or multivariable OLS, also known as multiple linear regression. Now look at our chart. This is our little baby chart here. Do you see it's just those two little data points? No problem. But now, what if we want to use all of these? What happens if our data now looks like this, where we have length 1, length 2, length 3, height, and width, and they're all linear? So what do we do now? Except width, we can actually just discount. Width is what's the, if you wanted to say feature extraction, drop width, because width is flatlining in the bottom here. But we're not going to do that. So that uses this formula, which I've put in here, far, far, far too small. Okay. Make it bigger. Don't move it around. If anybody wants to find for me the Lenovo trackpad stuff. Okay. So how do we do this now? So it's very, very simple. We actually will have multiple slopes. Each one of these variables clearly has its own slope. And we're going to assume an intercept of 0. But we're going to have this guy's slope, that guy's slope, that guy's slope, and that guy's slope. And we're going to use all of them. And how are we going to do that? Okay, so I am going to delete this here. No, I'm going to keep that. You need that. It's an explanation. Never mind. So let's go and be lazy, because we are allowed to be now. We can now say data analysis because we now understand what we're doing here now. So if we now go say, okay, data analysis toolpack, I would like to do regression again. And it says, okay, give me your Y range. And we're going to go, well, Y remains the fish's weight.
Sorry, Serena.
Yeah.
Apologies. I think I'm just low on thinking here. On the previous exercise,
Yeah.
for some extent, I was thinking that from the calculations that we have done, we will get to a point where we're now going to draw the line itself.
Yeah, we can draw
a perfect
the
line itself. If you can, maybe, I don't know, that's what I was thinking, that the end goal will be, once we have done all those calculations, we'll be able to have our intercept, and then we are able to draw the line with that specific slope, and then we are able to tell what is the perfect line, or the least perfect line in this case.
Yes, so we can actually go find that chart, but and you will see that our slope was actually very far negative. So if we could literally do this. We could literally go and say, okay, our slope was minus 900 and something. So, and you will see here, we don't start at 0. But anyway, our slope was minus 900 and something. So it starts back here and it incremented with 102. So we literally could draw that line. Absolutely, you could draw the line on a chart with the data. You could do that. But in machine learning, we actually do this thing that we've done once. And it's serendipitous, and why I'm using this data set, that we get this beautiful numbers here, which we'll talk about later. It's really serendipitous. Usually it's not that good. So usually the first time in machine learning, in the PDAN class, when we do OLS, what it actually does is it guesses. It chooses a random slope and a random intercept, draws a line, works out the error rate, goes like, oh, no, we stuffed up spectacularly. Let's change. And it uses something called gradient descent. Let's change the slope and intercept, and it will iteratively do it until that R value becomes the smallest, that R squared becomes the smallest possible value. And I can show you an example of that at the end so that you guys can see where we learn the best possible slope and intercept. We actually do this calculation. We are doing multiple times. We are lucky that we came out with an R square of 94 here. Normally, when you do your first iteration of linear regression with a dirty data set, your first R square is like 40, and you're like, oh, that's terrible. We have to go again and again and again until we get to the best place. Gradient descent tweaks your slope and intercept to find the best value over multiple iterations. Okay, and I'll show you an example of that in the slides, but I don't want to break your brains. Okay, for this one, because we have all of these little doodads here, you will see if we go do that data analysis toolpack thingy, it's going to give us an intercept, which is pretty much a little bit different than the intercept we first calculated, but not much. But then it is going to have multiple slopes. And in machine learning, these things are called your coefficients, and that's what a machine learning model learns. But it's going to give you multiple ones. And how do you read that? Always Google what you don't know. But in Excel, it's the first one, always like X variable. Oh, I lost the X there. X variable 1 will be the first variable from the left. Like in our case, because we highlighted the whole block in one go, it will be X variable 1, X variable 2, X variable 3, X variable 4, X variable 5, X variable 6. No, that's what we're calculating. Okay. So it's always from left to right. Unless you individually skip some, then it will be the first one is you highlight as X variable 6. If you decide not to use this one and then highlight that one also, that will be X variable 2. So it's always read from the ones you highlight first or the left to the right. Now, what do we do? So this formula, this formula tells us y hat equals this, and here it shows us up until P. It tells us here for when we have multiple features, y hat is the slope times x1. Okay, plus the slope times x2 plus the slope times x3. So what it means is that you will actually do this. If we look what we have here, we have B4, which is length 1 times with length 1's slope, plus C4 times with C4 slope, times D4 length 3, length 3 slope. So all you're going to do is say, actually, y equals feature times slope plus feature times slope plus feature times slope till I run out plus intercept. And that's how we do that. So you actually have each slope in the calculation. And we're going to go do it together now on the next slides, on the next thingamabob, so that you guys can understand. Okay, so let's go do our lazy. We're going to say we are going to use the data analysis tool pack. We want regression. It's going to remember my stuff from the previous highlight, which is also infuriating, but never mind. This is just why Python is false superior. Okay, we're going to say this is my y values, the weight. Okay, my x values is now not just height. We are taking everything. We are taking all of these into account. We're starting from left to right, dragging this whole range down. I hope it shows nice and clear to you guys that we're using everything. And then we say we would like to have an output range, and we're going to tell you where that output range is. Why don't you, this keyboard, why don't you just put it right over here? Thank you. And there it's got all of those different slopes. Now you guys are going to help you with this formula. I'm also running out of throat. So this formula tells us y, which we're trying to predict, equals length 1 times its slope. And then this dude, we have to F4, I think. We're going to look at the other formula I did. Okay. Plus length 2 times its slope. Plus length 3 times its slope. Plus height. Nope. Almost did it again. Plus.
Don't you need brackets?
I don't think so. We're about to see.
Okay, cool.
Sometimes I'm a bit of a cowboy. Sometimes it works out. Sometimes I cry. I'll tell you in 5 minutes. Plus the last one times its slope plus the intercept, which we also have to do that. Dun, 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 dun. It is working. And we'll do one with brackets below it so we can test it. Okay. What did I calculate? I don't know what the heck I did. Oh, it's residuals. Okay. And there we go. There it has calculated it for you. And it's actually not much different than we had in the normal OLS. This is 241. This one came out 225. Okay. Okay, so there we go. And that's how you do it when you take all of them into account. Let's test the brackets thing. Do you want me to do, yeah, it's got to be a lot. Let's do brackets. First, we have to remember the value. So let's stick that value over here so we can remember it. Near, that's bad. But stick the value, Serena, just the value.
You don't have to do the brackets just for me. I just, you know.
Why can we not experiment? Okay. I give up. Go try with your own brackets. Okay. Generally, I have not done this with brackets and it hasn't bitten me in the bum. But like I said, I can be a wee bit of a cowboy. All right. But there we go. That's our residuals. And there you have an example of multiple linear regression. And you guys, listen to me carefully. If you have this down, yeah, we will interpret it. We will interpret R squared. I promise. If you get this down, if you understand y equals mx plus b for one feature or 1,000 features, you understand linear regression, you understand logistic regression, you understand to a great degree neural networks, because they will just change their name, but they will remain the same thing. I want to show you guys something in a slide. First, I'm going to take you through the horrificness, which is my files. And what you see, we do have a campus shrink available and she can help you. Did I do that? So where did I do neural networks? I want to see if you recognize a little something in the neural networks calculations. My word, what is this? X1 times weight 1 plus X2 times weight 2 plus X2 times weight 3 plus B1. It looks a lot like linear regression to me. That's interesting. Okay, so that already helps us a lot. Let's go have a look at logistic regression. It would appear that if we use logistic regression, we do the same thing. We work out the equation of the line for a logistic regression. If you can understand this, your head is through. You are going to be fine. That is then now you stop stressing, it's over. You no longer stress. Okay. All right. Okay. So now we had some questions about, we have to sort of, what is this now? Logistic regression. I must use different colors in different sheets. Now we had a question about like, how do we go about how wrong am I? Okay. So let's go work out our boo-boos here. Oh, this is small. Why is that small? What have I done? So there's different ways that we can figure out how wrong we are. Okay, so what did I use here? This is just the normal quick, not multi, but it doesn't matter. We just have height and weight here, but it doesn't matter. We can do it with the other one as well. But let's go find our residuals, which is y minus y hat. Okay, let's get those residuals to understand per data point how many grams we were off. Okay, now let's go square them. Oh, I can see why this is happening. Hold on 5 seconds. Because I've made this into PDFs for you guys. I will upload them. And the minute I have ARC. Now things are going to get interesting, but we're also going to go find the absolute value, which is called ABS. Imagine. We're going to get the absolute value of the residuals as well. And we're going to talk about why we use these error rates. Okay. And the absolute value is just never, ever a negative. Okay. So let's look at our first thing. The first thing we have is mean squared error. MSE, one of the best known ways that we calculate how wrong we were. So we actually take the squared residuals and we just work out the mean. It's really difficult, huh? So to do mean squared error, in the OLS sheet, we already have subtract the actual values from the predicted values, square the results, calculate the average. I don't know how you guys are going to pass this course. It's hard, eh? Mean. Working out your mean squared error was an absolute nightmare. On average, we are that wrong. You want that number to be as small as possible. But then I've got in brackets here for you. It can be hard to interpret because we've squared stuff. We are no longer looking at grams. Okay, so now it's confusing. I'm 2962. What's off? I know it's bad, but how bad? And the other thing is, MSC is sensitive to outliers. Because let's go find a lack of fat boo-boo here. If we look at these residuals, I wonder, there's a potential outlier. Okay, do you see what happens to him if we square him? It exponentially increases the error rate. But at the bottom here is a really, really chunky fish. These fishes here at the back, this is definitely an outlier. Look at this one, 1,000. That's an outlier. And when we square, we exponentially increase that error. So it has a big impact on that error. Okay. Then they go like, okay, maybe that mean squared error is a problem. Maybe we should just take the root. Just calculate the root of mean squared error. Hold now in Excel for a second there. I've forgotten how to calculate the root. Is it root? Give me 5 seconds. And I'll always give you a spreadsheet with everything perfectly calculated for square root. Okay. So just go calculate the root. So we can say square root or squared. Hey, never mind. Do as I say. So we can just go work out the square root of our MSE, which we calculated over there. I know. Just let me click on the thing. Ooh, now I've stuffed it up. I will get there. And that automatically brings us back to grams. Okay. Right. It brings us back to say that we are on average 54 grams off. And we can then also just do the mean absolute error, where we can just say we've worked out the absolute values where we didn't square. And this one is not sensitive to outliers as much. We can say, okay, what is the average of this? Yeah, man. This is the times of the evening where I start realizing that I'm no longer a youngster. Okay, we can just take. Why is Excel so aggressive with the brackets? I know there isn't a bracket. Okay. I swear I know what I'm doing. It's very frustrating. Let me just close the bracket so it can just breathe. Why? Why are you like this, Excel? Flipping hell. There is our mean absolute error, which puts us at a bit 41 off. So these are the ones where we can say per gram per fish on average how wrong we are. And we actually use these then for that gradient descent, where we would come in our MAE or RSME or R squared be terribly high. And we were like, oh, bugger. Then we go back. And we get a better thing. But I just want to show you something here. Do you see your standard error here? You will see it come out over here for you. Okay, that's your mean absolute error. Then there are some other ones that we can look at. All right. So another one that we can look at, and these are all different ones, and I have a thing for you at the end of how we know which ones to use, but these are just evaluation metrics. So this one is the residual sum of squares, or the sum of squares residuals. To do this, you calculate the residuals, you square the residuals, and you add them all up. Ta-da! It's very hard. Okay. And then the other one is total sum of squares. And that is how we want to know the following. You know, it's really unfair to assume that fishes don't vary themselves. There is variability in Y. If we look at this, the weight, I mean, we have from 242 kilograms or grams or whatever, we have a fish of 1,000. There is variability in Y as well. And TSS is just the variability in Y. So we find the mean of all the observations, the mean of Y. So we go calculate the mean of Y, and you can see we've done that here. And we will go through this again, and you don't have to calculate this for your exam or your assignment. We take the mean of our Y values, Okay, so that our weights are y values. We calculate the mean of that. Okay, where the heck was I? And then we subtract each data point from that mean and add them all together. And that gives us this value. Although in this one, somewhere I did make a mistake. I'll have to go fix it in my TSS values. Or did I fix it here? No, I did fix it. Hold on, let me just see if I fixed the TSS values. No, I didn't. I'll show you guys what I did wrong here. I want you to see AC30. No, I did it right. That is the mean. It was on a previous sheet. So I looked at last year's stuff and I was wondering, why is this value so high? And I realized I clicked on the cell next to it. So we take each individual. Let's just show you guys this formula. Each individual value. So if you look here, we have G, which is weight. We'd say G1 minus the average of all the fish's weights, and we square it, and we add that up all together, and that gives us the variability in the fishes themselves. So that quantifies the total variation in the observed data. So how does y vary from itself? But none of these really matter, because what you really want is you want r squared. Okay, so r squared is a metric used to evaluate the performance of a progression model. We want that percentage accuracy, this 93% accuracy. And that's just these two numbers divided by each other. Your RSS divided by your TSS gives you your accuracy. You do not have to manually calculate this. It will be given to you here. Okay. Do you guys see it? All right. So you will actually get that. And you also, even in this table, get your degrees in freedom, all of that for p-tests, which Gareth is going to do with you guys. But those are the evaluation metrics that we use. The one that you report on most frequently is R squared. You don't really report on the others, except in Python in the machine learning. And then when we use gradient descent, it uses MSE. All right. Are you guys okay with how we work out our errors? Yeah, Nyasa?
Sorry, so I just want to take you back maybe to MSC. I wanted to check if maybe I was understanding properly. So
The mean
with
squared
the,
error, yeah?
yes, so if it's low MSC, then the predictions are closer to the actual values, right?
Yes, you want your
With,
MSE to be low.
oh, okay. And then it's the opposite, which means that would be bad if it's the
Yeah,
opposite.
if you had a low, yeah, if you had a massive MSE, you made big errors. If you have a low MSE, you did not a bad job. What you want to be high is your R squared. You want it to be as close. You can read it as a percentage out of 100. The R squared, you want that to be nice and low. Okay, I lost my R squared, but you want that to be nice and low. And you guys, I teach you to manually calculate everything so that you understand. Okay, because if you look at this value, if I just did the data analysis tool pack with you, if I didn't take you through this, and it's not pain, it's understanding. If I didn't take you through this value here would have precious little. You'll be like, oh, my R square is 94, but you won't even know what that is. You won't even know how we got there. You will go, oh, my standard error is 53, not knowing that's your mean squared error. You guys understand your mean root squared error and why they are there. And you will see these things in PDAN again. When I take you guys for PDAN, we look at the spreadsheet, we look at the code, we look at the spreadsheet, we look at the code, and we see how we get this own stuff out. And then if you understand this, you'll be good at your job because you understand what the heck is happening. And if your model is really weird, you know how to interpret it. But if you don't, you can't interpret these things. So let me take you through some slides. I put the following here for you guys. Here's evaluation. So I did a nice slide for you showing you the calculations on small numbers. And like I will say, a lower MSE indicates a better fit. For the roots mean squared error, why we do it, okay? And then it's useful when you want to understand the error in the same unit as the target variable. The mean absolute error is when you want to evaluate the model's performance without being influenced by large errors. And we see that here. The mean, where's your brain, Serena? The MAE here is 41. The RSME is 54. This is 41 grams, this is 54 grams. And this 54 grams is happening because we did that square and we squared that 1,000 that was most likely wrong. Okay, all right. Then is your total sum of squares, how it's, yeah man, gaan af hierso. Your total sum of squares and how it's calculated and why we do it. And there's your R squared. Yeah man, what am I doing? There's your R squared and how we calculate it. And that's all these things are. And you are, just remember, don't go through all of this, break yourself. You're just going to look at your spreadsheet. And this is why I gave you guys the spreadsheet. No, it's the wrong one. That's why I gave you guys the spreadsheet. We have calculated RSS up here, and we've calculated TSS, and it's literally just 1 minus the 2 over each other. Okay. All right. But you don't have to calculate this. You're very welcome to use the analysis tool pack. These things are here for understanding. Then, while you are still awake and you don't want to die, I've given you the key differences and why they are explained and some more information. And here I'm just going to show you guys gradient descent, okay, what it is. If you're going to look at these formulas and want to vomit, do not vomit, okay? You don't have to calculate this right now. All I want you to understand is the following. In machine learning, so in Excel, we've done this once. This is one iteration of OLS, okay? But if we look at Python, what the hell? I'm showing you guys my WhatsApp. I'm just going to close this and open it again. No, that's even not the right thing. So in machine learning, which is what you guys are really here for, if you're going to look at the linear regression formula in scikit-learn max iter. So what this tells you is that look at this linear regression. You now know this. However, we have the option to do this over and over and over again and to find the very best gradient, the very best slope and intercept. And in this guy, in this algorithm, which you guys are going to do with me in PDAN, there is a max iter value. Why is it not showing it here? And it's how many iterations do you want to do before we say the model converges? So what in the actual heck does that mean? Where is the max iter variable? Because it's usually 100, and then you have to come and change it if your model doesn't converge. What does this stuff mean? It means we have, in our little example here, done one iteration, and we have gotten an MSE. So we're using MSE as our cost metric, okay? This MSE can be smaller. So then what we do is we go like, I'm going to slightly tweak the slope and intercept and come calculate MSE again. And I'm going to slightly tweak the slope and intercept and come calculate MSE again. And I'm going to do that 100 times over, and I'm going to choose the best possible MSE. And we converge when we find that best possible value. When more calculations doesn't matter, we either go up and down in the wrong direction. That's why in machine learning, we do it zillions of times. And that's what gradient descent does. So now if we look at gradient descent, it's an optimization algorithm used to minimize the cost function in linear regression, many other machine learning models. The goal of gradient descent in linear regression is to find the optimal values for the model parameters, the slope and intercept. So if we use MSE as our cost function, there's MSE. This is a formula you're not even going to worry about, but it's the number of training examples, the predicted value, and the actual value. So all we're going to do is we're going to work out over and over and over and over and over and over and over again until we find the absolute best MSE by checking against. And you will learn at the end when you don't want to vomit, because last year I nearly killed the class when I showed them this. At the end, you will absolutely understand how we calculate it. You'll do it in neural networks. Here is what you need to know. It minimizes the cost function by iteratively updating the parameters M and B. The learning rate controls the step size. So there's just one thing that we have to understand about gradient descent. And I'm going to find that free whiteboard. If anybody has a nice free whiteboard, I mean, feel free to share. And someone actually, I have a tablet and a stylus. I must just, not be a doofy. So gradient descent looks like this. The picture for gradient descent, you're always going to remember it like a big fat U. Okay, it's got better names. And what actually happens here is this. Remember when I told you this, that we ended up with this 93% here is a very serendipitous data set. Okay, that doesn't normally happen. What will happen is we'll come and we'll say, okay, I'm going to do my OLS, and we're going to go, what is Y minus Y hat? So we're going to find our residuals or the average of them. We're going to go like, oh my word, Y was supposed to be 50. I have 0.9. This is profound. I have a 41 gram boo-boo. This is really bad, okay? So I actually have to change the slope and intercept a lot. I can make a big change because I was very wrong. So that's the learning rate. Then we make a big change to that slope and intercept, and then we go like, oh, okay, let me check again. And then we go like, oh, now you're at 22. And you go like, okay, I must still make a fairly big change, but maybe not that big. Then we keep doing this until this becomes smaller and smaller and smaller and smaller. And then here is where we converge. Here is where we start leveling out, where the calculations will be like, okay, with this slope, I get 49.9997. And then with the next one, I get 49.9996. And then I get 49.9998 and 49.9996 because I'm going too far this way. When those changes in the MSE is so tiny that it stops mattering, we say the module has converged and we have found the best possible slope and intercept. Are you guys okay? Yes. R squared should be close to 1. Okay. All right. What time is this class supposed to end? I think we have a half an hour more.
Yeah, 8:30.
At 8:30. How are you guys doing brain-wise right now? Right. Okay. There is a section of the curriculum. Yeah, my throat is fried. There is a section of the curriculum we still have to finish. But I tell you guys what, I'll go through the theory now and I'll make you a video on the prac, and I'll make a nice detailed video for you guys tomorrow and I'll upload it. Actually, there is already a video about it uploaded. All right. But it's just called ridge and lasso regression or shrinkage models. Okay. And all it is this. Okay. Okay. Don't freak out. It's drawing an alternate line that looks like it's a bit worse, but it's not. Okay, so what does this mean? I'm sure someone has done the bias and variability trade-off with you guys. Can anybody tell me what is the bias? I just put my head around gradient descent. I'm sorry, Josie. Okay, guys, I tell you what. Can I record you a nice video on ridge and lasso regression? And then what I'll do is in the PDAN class, we'll go through the spreadsheet quickly because it's literally 4 calculations and you cannot be in PDAN without SMAA. You are not a PDAN student if you haven't been a SMAA student. It's impossible. The entry for PDAN is SMAA. Yeah, Nyasha, as soon as I am able to get onto ARC. So what has happened is I'm a research scientist for Emeris. So I don't know if it picked up that I'm not like what do you call it? I'm an academic staff member. What is it? Anyway, both Nadia and me have been kicked off ARC. They know about it. They are trying to put us back. So the minute I can update ARC, I absolutely will. The reason I gave you guys that Google Drive is because Nadia and I are kicked off and Emeris itself is trying to add us back on. So I can't get onto ARC to do anything, but the second I can, I will update everything for you. Is that okay? I built ARC to look like this. Let me show you what I can do for you as soon as I have access to it. Maybe we should check. Maybe they finally fixed it, but I don't know because I checked just before your class. So normally, yeah, it's just a support course. Normally, I'll build your ARC to look like this, and will that work for you guys? So this is PDAN, where I'll put in the lesson video. I'll link it in for you, your slides, where you can practice flashcards, all of this. I'll add this in for you as soon as I can. Okay, and then you'll see there's always a playlist that is all the videos for the recordings are uploaded to there. So as soon as I can set up ARC, I will. When is the assignment due? Anati, that's an excellent question. Let's go look. And what we can do is when I see you guys in the next class, we can go through the assignment. So if I see you next week, Tuesday, and I will also make you a video about the assignment. Did you guys watch the short video I uploaded for you about how we actually got to the OLS formula, and did it help you? Click on my academics, I think. Program assessment schedule. Did I click on the right thing now? Ah, this is what's happening. Can somebody please give us the due date for the assignment? Do we have an exam for this module? No. This is how this module works. You have assignment 1. And assignment 1 is KNN, linear regression, and GAMS. Don't think there's anything else. Maybe some p-values, blah, blah, blah. But Gareth will have a workshop with you guys for that. Then, and I have in the end of this slides, and I'll also upload the video for you guys after ridge and lasso regression, which is very easy. Enjoy my Barbies. I did do for you guys exactly how to get a p-value. All of it is here. No? What did I do with it? What did I do with the p-value stuff? I do have for you guys how to work out your p-values, what your F-test is, what your F-score is. I will find it and I will record it for you. But Gareth is doing a workshop with you guys for this, and Gareth is doing this because he absolutely adores like working out, using t-tests and all of these things. So he's your dude. And he will do a workshop. I will ask Kafeni when, and I'll put it on the group tomorrow. Okay, so the assignment is on the 2nd of April. So you guys, you have a week in which you get to submit your assignments because we realize you're working people. So we give you a week range in which you can submit. In the next class, I will go through the assignment with you in detail. When are you getting your first ICE task? Okay, Bianca, I am actually only taking you guys for linear regression, logistic regression, and ANNs. I'm going to ask Nadia to update you guys about when you're getting your first ICE task, or I can say to Nadia, we have to put up an ICE task for linear regression because it is in your assessment, but I want to go see what is the most weighted question in the assessment, like what counts the most marks, and then we'll put up an ICE task for that one. So, and I'll make it auto-marked so that you can see where you went wrong and went right before the assessment. Will that work? Okay. There is no exam. There's a summative assessment. It's like a big assignment. Tabiso.
Yes. One question that I have just before you close. Look, understand what we have done today and all the videos that you have shared with us. Is it possible that perhaps maybe you know of a source, or anyone within this forum who knows of a source that one can use to have more example? I think I've looked at the species on KNN so many times, and I've looked at this one so many times as well. and there's too much information out there, and I can't really find a very nice source of questionnaire or practical questionnaire that one can use to sort of do more and more of these practices.
If you wanna, okay, so a nice YouTube channel to follow is StatsQuest. He does sing. I am sorry. Okay, but you guys, StatsQuest has been around for ages. It was around when I was, so this is from the University of Chapel Hill. I cannot tell you, and you see here's all the things we do. I cannot tell you the amount of students that has passed statistics based on this YouTube channel alone. Okay. So there's definitely Josh Strama, who I can recommend if you can suffer the singing. Okay. All right. Then another thing that you can do is to just practice. Is if you want data sets, you guys have to all sign up for Kaggle anyway. But there's so many places to find data sets. But if you just say, if you just Google good data sets for linear regression, and then do yourself and do an intermediate, like take a bit of a messy a bit of a messy one. So you'll see there's the medical insurance cost data set, the video MPG data, the students performance records. Don't even do that, that's too easy, but it will give you a list of data sets. Okay, and then if you go onto Kaggle, and there's one from Geeks for Geeks as well, but if you go, oh, I love the red wine data set. If you go into Kaggle and you then go say, what it's going to do is it's going to find you the red wine data set. I like this one because it makes you work hard. Then you go to download and you say download data set. Then it will give you, I don't know what is in my downloads. How risky is this? No, it's okay. Then you're going to extract this. And inside there, you will find a nice data set that you can use. And then it's a good idea to have a Google about what to predict. I know people like to predict sulfur in wine. You can use this guy for classification, but a lot of people like to predict sulfates because apparently that's what gives you the hangover. Or can you use sulfates to predict alcohol? So you can, there's lots of data sets that you can use. And look at Josh Strama, but there was somebody else that I've forgotten about now that was also really good. I'll find all of the old sources I have for you, and I'll also ask Nadia who she refers to. Another place that's really nice to look at is medium.com and towards data science. Okay, so medium.com linear. Oh, Khan Academy will also be good. But for medium.com, you get a certain amount of articles for free. The rest you have to pay for. I think you get 10 a year. I have a subscription. It's 90 Rand a month. But you can then also go through, look at these. They're also nice. Same kind of things to look at. And the only thing is to practice. And I'll find some other people that make videos, because there was the nursing, I know it sounds weird, but it's chemistry people are deep into this. There was the nursing college of somewhere that I had cracker videos. I'll find it for you. Did that answer your question, or did I just rattle off a lot of stuff?
I'm just going to stick with the first one first and play around.
Yeah. Yeah, Scikit-learn is the business. It's Itumeleng. It's wonderful to look at, and it also gives great knowledge. Bianca, your hand is up.
Yes. I just have a question regarding the assignment.
Yeah.
So question 2 is regarding the linear regression. It's 40 marks, but we need to submit a PDF report. So I'm not sure if there's maybe an example doc about maybe explaining the format we need to submit it in.
Is this for SMAA?
Yes.
So, yeah, I need to go look at that assessment quickly. So for the report, I wonder why they want a PDF report. That's weird. Okay, I can give you guys the structure of the report that they use for PDAN as well, which is basically a structured report that lets you talk through your thinking. I'm going to say, for the markers' sake, keep those reports brief, or they're going to lie on the floor crying. Okay. All right. And let's go through that assignment in detail. Is it already released? What am I doing? The only problem is, just like I said, my things are a little bit broken. Let me go back here. Let me see. And they have said that they're going to fix this for me and Nadia. But do you have the assignment? Okay, I'm going to break you if I do it now. But okay. I can see everybody's assignments. Okay, let's go look at that assignment just briefly. I want to see the report question that was just asked. Okay, let's have a look-see. But in the next class, before we do anything, I think we will go through SMAA. So here is the assignment. Oh, that's bad. Okay, this is theory. Here is your linear regression. Okay, they want a report. I will give you guys the report. Okay. I will give you a template for a report. Actually, Gareth has the nicest report template that he shares every year with the PDAN students. I will ask him for the template of that report. So technically, you guys can already do this assignment, because this is just research, like describe nominal, ordinal, interval ratio scales. What is a training error versus a test error? What is a GAM? The bias and variance trade-off. See why we have to do lasso and ridge in the next class? Okay. All right. And then here's your linear regression question. It is hypothesized that a student's performance in an examination depends on the number of hours spent studying as the number of past examination papers reviewed. And so it's two variables. You're provided with a data set, multilinear regression, containing the following features: hours studying, preparation, exams taken, and marks. You guys, this is marks for jam. Gareth will go through for you too. Pearson's correlation for 5 marks. That Coddle thing, we just equals Coddle, highlight. I'm going to be ill. Okay, you're going to get 5 marks for that, for jam. Oh my word. You're going to use the analysis tool pack. Dun, and you're going to do it. And then you're going to have to tell them what is, oh no, man, you guys. Okay. Do you see how easy this assignment is? Interpret the R squared. And then this Gareth will do with you in the next couple of weeks. And then you have to predict one student's things using the intercept and slope that you've gotten. So I will go through the assignment in detail, but it's really not hard. Bianca, yes. And I will give you your hand still up. I will give you guys a report template. I'm just making notes myself here. So it is video thingies. And it is a report template. Okay, gotcha. And then you guys at WhatsApp group, just let me know if you need something. I generally look at it. Okay, so Susan, can you explain to me, where is the data set for the regression analysis? Okay, for the assignment, or because for the assignment, when you go into the assignment folder, you'll see there's preloads. Okay. And you will then download those preloads. But I'll just quickly download them and give them to you guys. And then I'm going to close this off, and I'm going to close this off. So here, I don't know if they're going to let me add them here. Clearly not. I'm going to stick them for you on WhatsApp. However, we are going to be just very careful of me opening my WhatsApp screen on the moment, because we're working on memos. Josie, could you give me more details that you mean? I'm going to just quickly, here is the link where you can find your assignments. Just going to follow this guy over here. Oh, that's nasty. Okay, and you will get the assignments. Okay. And then, Josie, do you mean the link for do you mean the data set that's currently on ARC that I can't log on to? Do you guys want a copy? Because, Dominic, did you not download that data set today and work on it?
Yes, I did, Serena.
Can you share it with people that's looking for it getting stuck on ARC?
Sure, no problem.
So will you stick it on the WhatsApp group? Okay.
Stick it
Right.
on the team. I can also stick it on the Teams chat.
Yeah, I'll put it everywhere. Proliferate that data set. And then go and do the work on that data set. But you guys, for the assignment, I would urge you to do that linear regression question now of the sections that you can do. And when they say interpret your R squared, you're literally going to say that, you know, based on a student's study times and previous exam papers, we can predict with 90% accuracy what their scores in an exam will be. That's it. For the assignment. Okay, so we've got that, Josie. I'm going to put it on. Yeah, no stress. Don't worry about it. We'll also stick it on the WhatsApp group, and as soon as I can get onto ARC, I'll start putting stuff on ARC for you. I can also download you guys some data sets if you want to and make them available on that Google Drive for you to practice. All right. So, yeah, Bianca.
Sorry, last question.
No, there's no problem.
Just regarding question 1, are we allowed to use websites when we try to find the answers, or are we
You
only allowed
must.
to use
Yes.
articles?
You can use websites, articles. There's no rules. So it
Okay.
doesn't have to be, yeah, it doesn't have to be an academic article as long as you reference.
Okay, cool. And then how do we reference a YouTube video? Can we use that?
Okay. So to reference a YouTube video, you guys, I'm going to find out for you if you have to do ACM or Harvard, but I assume it's going to be Harvard, and it's like a flavor of Harvard we use, which I forgot. Isn't it Anglia?
Serena, I'll share the Harvard referencing style on the WhatsApp group.
Thank you very much, because I work in computer science and we reference ACM, which is kind. Okay.
Yeah, no, it's Harvard. It's Anglia Harvard. I'll share the referencing guide on the WhatsApp group.
Okay, yeah, so it's Anglia Harvard that you guys have to follow. Sorry for that. And you know what? The rule is just reference. Okay, even if you think you're referencing for referencing's reference sake, just reference. You know what is going to phone you and tell you there's too many references, but they sure as hell going to tell you if there's one missing. Okay, so before we call it a night, my things that I have to do, you guys, is find the good video resources that I know about. We need a report template. I need to get my butt onto ARC to fix all of that. I have to be sure that when we have our next class, we go through the assignment in detail, not a quick squiz like we just did. And then I will make a video for you guys, or share the video for Ridge and Lasso regression, or shrinkage models as they're called, and I'll quickly recap it as well in the beginning of the next class, because in the next class we're moving to logistic regression, which is super easy, super duper easy. Okay, all right, now
I've also sorry, Serena, I put the linear regression exercise also on the WhatsApp group for anybody that wants to complete it. It's not that hard. It's actually quite easy to understand.
Yeah, and you guys must help each other share stuff on that WhatsApp group. Like, yeah, the number one thing that I remember from my undergrad class at UCT was how much my undergrad was at Potch. The other stuff was at UCT is how much we shared with each other. Like, we really helped each other, and so help each other. If you have a cool link, share it. Okay, and also sometimes I learn, like sometimes you guys share very nice stuff and I'm like, hey, I didn't know that. Okay. Can I ask, are you feeling much calmer now, or are people still feeling freaky outy? If you have to compare your stress levels to last week, where are you? You're just going to say nothing? I'm going to go suck strepsils for nothing. Okay. What I want you to understand is the only thing that was different between this week and last week was a repetition. Repetition, repetition, repetition. We just went through the same stuff again. And repetition is the answer to understanding this stuff. Practice, practice, practice. Now, go have a lovely evening. I see you guys for 2 more lessons, and then I hand you over, I think, back to Daryl, either Dr. Tom. She told Tom, I mean, she's a gift. You guys are so lucky to get her for trees. And then I see you again for neural networks at the end of the semester. Okay, so 2 more classes with me, and then over to the other lecturers. Right. Have a good evening. See you next week.
Cheers.
Yeah,
Thank
my
you,
stupid
Serena.
PC.
Much appreciated.
No
Thank
problems,
you.
guys. Good night.
Bye.
Bye. I have to stay till everybody
Bye-bye.
leaves, so we have. Oh, I can just stop the recording now. We've changed the settings.
Hi, Serena.
Night, everybody.
Hi, Serena.
Hey, Kat, yeah.